Ford's EcoBoost engines show up in just about everything these days, from compact cars to full-size trucks. They promise better fuel economy without giving up power, and for many drivers, they deliver just that. But at the same time, they've also gained a reputation for some frustrating issues, like coolant leaks, timing problems, and turbo failures. In this video, we'll take a closer look at the full range of EcoBoost engines, what makes them popular, what problems they've faced, and why people either stick with them or stay away. 3 cylinders. Ford's 1.0-liter EcoBoost engine made its debut in 2012. It was developed as part of Ford's global strategy to downsize engines without sacrificing power or efficiency. Despite its tiny displacement, it packed enough punch to serve as the primary engine in compact models across multiple markets. Manufactured in Cologne, Germany, Craiova, Romania, and Chongqing, China, this 3-cylinder turbocharged inline engine made headlines from day one. Its design footprint was so compact that Ford famously compared it to the size of an A4 sheet of paper. But its most revolutionary feature was its innovative use of technology to overcome the inherent drawbacks of a small engine. It featured direct fuel injection, variable valve timing on both intake and exhaust, TVCT, and a single-scroll turbocharger that gave it performance levels close to a traditional 4-cylinder. What made it truly groundbreaking, though, was the way it handled NVH, noise, vibration, and harshness. Normally, 3-cylinder engines struggle here, but Ford introduced a specially balanced flywheel and advanced engine mounts to make the experience smoother. In later updates, it got even more refined. The 2017 refresh introduced cylinder deactivation, the world's first on a 3-cylinder, alongside a dual-mass flywheel and a vibration-damping clutch disc. Then came the 2019 mild hybrid variant, which added a belt-driven integrated starter generator, allowing regenerative braking and smoother stop-start functionality to save fuel and reduce emissions. It's no surprise, then, that the 1.0-liter EcoBoost won the International Engine of the Year award 6 years in a row, from 2012 through 2017, cementing its status as one of the most acclaimed small engines of the modern era. Over the years, this engine has found a home in vehicles like the Ford Fiesta, Focus, EcoSport, and even the Puma. But the 1.0-liter EcoBoost is also the reason some owners have come to distrust Ford's modern powertrains. One of the most notorious issues was its wet timing belt system, which runs in engine oil and was intended to reduce friction and improve efficiency. Unfortunately, early versions suffered severe degradation, with belt fragments clogging the oil pickup screen, leading to oil starvation and catastrophic engine failure. Head gasket failures were also common in early builds, often undetected until coolant loss led to overheating. One of the most significant recalls happened in 2024, when over 300,000 vehicles in the U.S. were recalled due to overheating nylon coolant pipes and faulty oil pump drive belt tensioner. Ford replaced the parts and offered some owners compensation, but by then, class action lawsuits were already circulating, particularly in the UK, where affected drivers accused Ford of downplaying the risks. The 1.5-liter EcoBoost engine, part of Ford's Dragon engine family, was introduced in 2017 as a more powerful 3-cylinder alternative to the 1-liter EcoBoost. With a smaller physical footprint, fewer moving parts, and new combustion strategies, the 1.5-liter offered impressive output, 181 horsepower and 190 pound-feet of torque, while still delivering lower emissions and better fuel economy. It's built in Ford's factories in Craiova, Romania, and in India, where much of the Dragon engine family is produced. Technologically, this engine took things a step further than its 1.0-liter sibling. In addition to direct injection, it introduced a dual injection system, combining port and direct fuel injection, to reduce carbon buildup and optimize combustion at all RPM ranges. It also featured cylinder deactivation, allowing it to run on just 2 cylinders under light load conditions. Ford was so confident in this setup that it used the engine in heavier crossovers like the Ford Escape and Bronco Sport, particularly in trims like the Escape SE and Bronco Sport Big Bend throughout the 2020s. Like the 1.0-liter, it uses a wet timing belt system for the oil pump, which was a key efficiency choice, but also became a long-term reliability risk. That risk would eventually catch up to Ford. One of the biggest problems with this engine is coolant intrusion, specifically coolant leaking into the oil system through the oil cooler or between the cylinder head and the block. This led to oil dilution, poor lubrication, and eventually engine failure if not caught in time. Ford responded with several technical service bulletins addressing these symptoms, but in many cases the damage was already done. Then came the issue with the high-pressure fuel injectors, which were prone to cracking. In some cases, this led to fuel leaking directly into the engine bay, a potentially hazardous situation, especially in the presence of hot components. Add to that turbocharger failures, caused by insufficient lubrication or thermal stress, and the list of issues became hard to ignore. In 2024, Ford began a series of recalls and software updates, particularly targeting the wet belt system and coolant intrusion risks. Some owners report good experiences, with Bronco Sports and Escapes passing the 100,000-mile mark with minimal issues, especially those who adhered strictly to maintenance schedules. And while Ford has made moves to improve the design, the memory of premature failures, dealership runarounds, and lawsuits has stuck. The 4-cylinder EcoBoost engines. The 1.6-liter EcoBoost 4-cylinder was one of the earliest entries in Ford's turbocharged downsizing strategy, debuting around 2010 to replace the naturally aspirated 2.0-liter Duratec engine. It quickly became the backbone of Ford's compact and midsize lineup, offering a respectable 178 horsepower and around 184 pound-feet of torque. This engine was built at Ford's Bridgend plant in the UK and in other facilities across Europe and North America. While it wasn't as flashy as later EcoBoost engines, it brought advanced turbocharging and direct injection to mass-market models at a time when few competitors offered similar tech. It also featured TVCT on both cams for better power and emissions balance. It powered a wide variety of vehicles, from the 2011 to 2017 Ford Fiesta ST and Focus SE, to the Escape, Fusion, and even some European models like the C-Max. In the Fiesta ST especially, this engine earned a loyal following, thanks to its punchy mid-range and excellent tuning potential. The ST's version featured uprated internals, stronger cooling, and different mapping that made it a favorite among the hot hatch crowd. Tuners love it for its responsiveness, and it's common to see Fiesta STs with upgraded intercoolers, turbos, and tunes pushing well over 250 horsepower reliably. But the love didn't last. One of the most notorious problems with 4-cylinder EcoBoost engines is coolant intrusion into the cylinders through a groove cut into the open deck block for its passage. Other most significant issues were related to overheating, turbo failures from oil starvation, carbon buildup from direct injection, and high-pressure fuel pump problems. In 2012, a massive recall was issued when Ford discovered that overheating engines could lead to cracked cylinder heads and engine fires. The recall included software updates and, in some cases, hardware fixes. The newer 1.5-liter 4-cylinder debuted around 2014 in global markets and later expanded into the US lineup, offering slightly improved power and fuel efficiency, along with better thermal management and emissions performance. Like its predecessor, it was built with an aluminum block and head, turbocharged, and used TVCT and direct injection. It powered newer variants of the Fusion, Escape, and Focus, with output ranging from 160 to 181 horsepower, depending on tune and trim level. However, it still suffered from the same fundamental challenges: coolant leaks, overheating, and turbocharger issues. While the engine received an improved cooling circuit and an updated head design in later years, it never fully escaped the shadow of the problems that plagued the 1.6-liter it was meant to replace. The 2.0-liter EcoBoost engine made its debut in 2010 and initially built at Ford's Valencia engine plant in Spain and later at the Cleveland engine plant in Ohio. This inline-4 power plant featured an open-deck die-cast aluminum block, cast iron cylinder liners, forged connecting rods, oil-cooled pistons, and a direct injection system paired with a single-scroll turbocharger integrated into a water-cooled exhaust manifold. Its twin-independent variable cam timing enabled better control of power delivery and emissions. The first-gen output varied from 200 to 250 horsepower, depending on application. In 2015, Ford launched a significant mid-cycle refresh. The engine received a new twin-scroll turbocharger, improving low-end torque and throttle response by separating exhaust pulses from cylinders 1 to 4 and 2 to 3 to reduce turbo lag. Updates also included revised internals, aluminum cylinder block and head, improved fuel injectors, and a new intake manifold design. It powered a wide array of models from the 2012 Focus Street to the 2022 Ford Maverick and Edge Titanium. In the Bronco Sport Badlands and Escape Titanium, it was tuned for torque-rich drivability, offering up to 250 horsepower and 280 pound-feet. That said, the engine wasn't without flaws. Early builds, especially in the Escape and Fusion, suffered from internal coolant leaks caused by casting porosity around the cylinder sleeves. Though Ford issued multiple technical service bulletins, many customers were caught off guard, with some paying out of pocket for full engine replacements. A more persistent problem involved timing chain tensioner failure in high-output applications, notably in the Focus ST, which caused timing slack, misfires, and in rare cases, piston-to-valve contact. Turbo failures were also reported, often related to oil supply problems or excessive thermal stress, especially in aggressively driven vehicles. The 2.3-liter EcoBoost, introduced shortly after, was essentially a performance evolution of the 2.0, built to meet the demands of sportier vehicles. It was first seen in the 2015 Mustang EcoBoost and later became the beating heart of the Focus RS, Ranger, Explorer ST, and Bronco. This engine shared its core architecture with the 2.0, but featured a strengthened aluminum open-deck block, revised crankshaft, larger water jacket and oil passages, and forged internals. It also received a high-flow cylinder head and an advanced Honeywell Garrett twin-scroll turbocharger, which dramatically improved boost delivery and output. Peak figures reached up to 350 horsepower and 350 pound-feet of torque in the Focus RS, a car that became iconic for its AWD torque vectoring and aggressive power delivery. Tuning potential on the 2.3 EcoBoost is massive. The Mustang EcoBoost community regularly pushes 400 to 500 horsepower with simple bolt-ons, upgraded intercoolers, bigger turbos, and E85 tunes. It's considered one of the most mod-friendly Turbo 4s in Ford's history, following the footprint of the classic 2.3 Lima Turbo from the 80s. The Focus RS, in particular, drew huge aftermarket attention, although it came with its own set of problems. The biggest headache came in the form of head gasket failures in the 2016 to 2017 Focus RS. Ford mistakenly used a Mustang head gasket in the RS, which didn't properly seal coolant passages. The result was coolant intrusion into cylinders, white smoke, misfires, and eventual engine damage. Apart from that, turbo issues plagued some Ranger and Explorer owners, especially under heavy towing, where insufficient cooling led to premature turbo seal wear. The 6 cylinders. The Ford 2.7-liter EcoBoost V6 made its debut in 2015, first featured in the aluminum-bodied F-150. It arrived as a more compact and technologically advanced alternative, aiming to deliver V8-level torque in a smaller, lighter, and more efficient package. It is produced at the Lima engine plant in Ohio and has since become a staple powertrain across Ford's truck, SUV, and crossover lineups. This engine features a 60-degree V6 layout, dual overhead cams, for valves per cylinder, and twin-independent variable camshaft timing. It uses twin single-scroll turbochargers and a CGI, compacted graphite iron, engine block, the same rugged material often reserved for diesel engines. Paired with aluminum cylinder heads and an integrated exhaust manifold design, this setup allows for faster turbo spool, reduced lag, and excellent thermal control. In the second generation, Ford added dual fuel injection, combining direct and port injection to improve combustion and reduce the notorious carbon buildup seen in earlier direct-injected engines. The second generation arrived in 2018 with deeper internal upgrades. Stronger cam phasers, redesigned turbochargers with electronic wastegates, higher pressure EGR, plasma arc liner coatings, and a variable displacement wet belt-driven oil pump, all aimed at improving power, efficiency, and reliability under high-load conditions. It's typically paired with Ford's 10-speed automatic transmission for smoother gear transitions and greater towing flexibility. The F-150 with this engine can tow up to 8,500 pounds and haul over 2,200 pounds, numbers once reserved for larger V8. For enthusiasts, the 2.7 EcoBoost has built a strong reputation. Its stout CGI block, dual injection system, and responsive twin turbos make it highly tunable. With just a software tune, owners regularly push it past 400 horsepower. You'll find this engine in a broad range of vehicles. In the 2015 and up F, 150 Lariat, and XLT trims, it's praised for offering the perfect middle ground between the fuel economy of a base V6 and the power of a V8. In the 2015 to 2018 Ford Edge Sport and 2019 to 2023 Edge ST, it delivers lively acceleration in a performance crossover package. The Lincoln MKX from 2016 to 2018 offers a more refined take on the same formula. And in the 2021 and newer Ford Bronco, especially in wild track and Badlands trims, it's proven itself with impressive low-end torque and trail capability. In global markets, it even powers the 2023 Ranger Raptor, tuned for off-road punishment. The first-gen 2.7 suffered from oil pan leaks, common in 2015 through 2017 builds, due to RTV sealant failure. Ford responded with a redesigned oil pan and issued a technical service bulletin to address the problem. Another concern was timing chain rattle, particularly in 2016 to 2018 models. While not catastrophic in most cases, the issue led to rough cold starts and long crank times. Ford eventually revised the chain tensioners and geometry to improve long-term durability. Then came a more serious problem in the 2021 and 2022 model years. A batch of defective sodium-filled intake valves, supplied for second-gen 2.7 used in the Ford Bronco and select F-150s, were found to be vulnerable to cracking. Under load or heat cycling, these valves could shatter, causing misfires, loss of compression, or even complete engine failure. Ford responded with a technical service bulletin and covered full engine replacements under warranty. Ford's 3.0-liter EcoBoost V6 debuted in 2016 as part of the Nano V6 engine family. Designed to sit above the 2.7-liter EcoBoost, but below the larger 3.5-liter in both physical size and power output. It is a 60-degree V6 with dual overhead cams and 4 valves per cylinder. It uses twin turbochargers, each feeding a bank of cylinders, allowing for balanced airflow, strong low-end torque, and minimal lag. The engine features aluminum cylinder heads and block construction for weight savings and improved thermal efficiency, and like its siblings, it uses direct injection and twin independent variable camshaft timing, TVCT. In terms of longevity, the 3.0 EcoBoost is still a relatively young engine, but early reports from Explorer and Aviator owners show strong reliability into the 150,000-mile range with routine maintenance. The 3.5-liter EcoBoost V6 stands as the flagship of Ford's EcoBoost engine lineup, especially when it comes to towing power, torque, and all-out performance. First introduced in 2010, this engine revolutionized Ford's truck segment, delivering V8-level grunt with better fuel economy and a lighter footprint. It quickly replaced older naturally aspirated V8 in the F-150 and Expedition, and even made its way into performance models like the F-150 Raptor and Ford GT. This twin-turbocharged V6 features an all-aluminum block and heads, a 60-degree V-angle, and dual overhead camshafts with twin independent variable camshaft timing. It was the first EcoBoost engine designed from the ground up specifically for trucks and high-performance use. In its current form, the 3.5 EcoBoost uses dual fuel injection, combining both port and direct injection, for cleaner combustion, better fuel economy, and reduced carbon buildup. It also employs a robust cooling system, electronically actuated wastegates, and a beefy forged crankshaft and internals, especially in high-output variants. The first generation, launched in 2010, produced between 355 and 365 horsepower, with torque figures hovering around 420 pound-feet. The second generation, arriving in 2017, added dual-fuel injection, improved cam phasers, upgraded turbochargers, and a redesigned oil system. Output climbed to 375 horsepower and 470 pound-feet in standard trims, with the Raptor's high-output version hitting 450 horsepower and 510 pound-feet. Then came the PowerBoost hybrid variant in 2021, which combined the 3.5 EcoBoost with a 35-kilowatt electric motor and a 1.5 kilowatt-hour battery pack. Properly equipped, F-150s with this engine can tow over 13,000 pounds, with payload capacities pushing 3,000 pounds. The engine is also a favorite among tuners, thanks to its overbuilt internals and massive aftermarket support. With a simple ECU tune, the 3.5 EcoBoost can see gains of 70-plus horsepower and 100 pound-feet of torque. Add upgraded intercoolers, larger turbos, and exhaust systems, and you're easily pushing 600 horsepower, especially with the second-gen or Raptor versions. Applications for the 3.5-liter EcoBoost are widespread. It powers a wide range of Ford vehicles, including the F-150, Expedition, Explorer ST, and Transit vans. High-output versions are found in the F-150 Raptor, Lincoln Navigator, and even the exotic Ford GT, where it's tuned for over 650 horsepower. However, despite its performance and versatility, the 3.5 EcoBoost hasn't been free from issues. One of the most common early problems was timing chain stretch, particularly in first-gen engines. Owners reported startup rattle and check engine lights. Ford addressed this in 2017 with a new dual-chain setup, one for each cylinder bank, along with improved tensioners and lubrication pathways. Another widespread issue was cam phaser noise, a clunk or rattle heard on cold start due to phasers locking up or failing to advance properly. Ford has since updated the phaser design and issued technical service bulletins for the fix. Intercooler condensation was a problem in humid climates, especially on 2011 to 2014 F-150s, where moisture would collect in the intercooler and get sucked into the engine under heavy throttle. This caused misfires and sudden power loss. Other notable issues include plastic oil pan leaks, turbocharger failures from oil starvation, valve cover cracks, and vacuum pump breakdowns. While none of these issues were universal, they highlight the importance of quality oil, timely maintenance, and updated components, especially when shopping for a used EcoBoost truck. Fortunately, Ford has continued to refine the 3.5-liter EcoBoost. The second-generation and PowerBoost versions are significantly more reliable than their early counterparts. With proper care, many owners report these engines crossing 250,000 miles with no internal rebuilds.